Hello, welcome to this session on how Solimar can help you to get the maximum value related to inkjet printers. This session discusses various inkjet related topics to help you get the most from your printers and applications. Whether you have an established print center or are looking to implement an inkjet for the first time, this session should have something for you. The topics this session covers are related to adding value to current applications, running production most efficiently, cost saving strategies, along with revenue sources beyond printing. Some of the information is common to inkjet workflows, and we also hope to point out capabilities and opportunities that you may not have been fully aware of. These topics are supported by Solimar's overall chemistry platform, which has earned various industry awards over the years and has provided many companies with cost savings and streamlined operations. These concepts have evolved over our 30-plus year history of providing solutions to our diverse customer base that ranges from small implants to Fortune 100 companies and the largest service providers. Our innovations and experience with a wide variety of print and electronic presentment has led us to being recognized by our partners and industry peers in various ways over the years. Many of these concepts can be applied to inkjet workflows to help foster the best production environment you can have for cost savings, efficiencies, and less stress for users. The popularity of production inkjet printers for implants, direct mail, and transactional environments has grown significantly for several reasons. Inkjets not only provide high-quality color output at very high speeds with lower-cost inks compared to toner, but can completely overhaul several print-related processes. A white paper factory means reduced pre-printed shells and inventory, and most jobs can follow a single process from pre-press to distribution. Inkjets have the flexibility to be able to print a wide variety of work from color marketing pieces, statements, to books, all in a streamlined workflow that can dramatically increase productivity and reduce the setup time between jobs. Moving on to optimizing inkjets, the concepts covered in this session are part of our overall suite of solutions that provide print file conversions, production job management and tracking, host-to-device connectivity, document reengineering, postal savings, and online presentment and archiving, along with many ways to reduce output delivery costs and gain efficiencies in production inkjet workflows. With a GUI-driven design that doesn't require complex programming, the solution enables companies to rapidly implement inkjet workflow processes. Typical implementation time is a matter of days as opposed to long, drawn-out, complicated science project-type solutions that require lengthy implementation times with the expense of a lot of custom services that are more difficult and costly to maintain and support. The typical workflow we use to support inkjets is to standardize the input data to optimize PDF files. Each job is then indexed to identify the mailpiece boundaries and obtain information about each mailpiece. Based on this information, the output can then be enhanced at a mailpiece, sheet, page, all the way down to a specific field level. This can integrate with external systems such as postal software, reporting and archive systems, along with existing processes. The enhanced output is then organized to support printing and finishing along with e-delivery distribution. To onboard applications to inkjet workflows, a transform of the print data is commonly required. Inkjet printers typically support either IPDS, PostScript, or PDF. This leaves a gap for other print languages that could be in a production environment. This table shows the print languages that the chemistry platform can convert into what inkjets support to enable support for application output that otherwise would not be compatible. The transforms are commonly used to enable transactional print data to run on inkjets and enables the onboarding of applications into the Solimar chemistry platform, which leverages PDF capabilities when enhancing existing application output. The PDF-centric workflow also enables companies to have a common platform for managing transforms and driving printers. The conversions also include data optimizations, which are especially useful for PDF files that may not process efficiently for the rated speed of your inkjet. You can also trap for the problem files before they interrupt production in the first place. Now that we can get your output files to work on the inkjet using the conversions, we'll move on to our Rubica solution, which is the enabler for many inkjet workflow concepts. Rubica supports enhancing and modifying current output, so changes don't need to be made to the application that is creating the output. This is especially beneficial for companies running host applications that are difficult to make changes to, or where some of the inkjet concepts we'll cover are not possible. With Rubica, the output enhancements are done post-composition, so you can continue to compose the output as you do today, but move into the benefits of inkjet printing. The solution provides a wide array of functionality to meet the goals of inkjet workflows and is modular, so you can start with what you need and expand as your requirements grow. The first functionality many companies want to implement with their inkjet is moving to a white paper factory workflow. This typically involves eliminating pre-printed stock and printing the static form information as an electronic underlay on the fly for each sheet to replicate the pre-printed shells, which provides opportunities to reduce costs in several areas. For example, storage space for paper rolls is reduced since you don't have to stock rolls for all the variations and just stock blank rolls. Underlays can be updated electronically, which eliminates outdated stock waste and shortages. Managing inventory becomes easier as there are less stocks to manage, which can also help with supply chain purchasing issues. And the reprint process is more efficient as they can be done on plain stock rather than loading pre-printed shells in the printer to run a few pieces offline from production. A white paper workflow also enables conditional content to be added dynamically to each page at runtime. In addition to pre-printed stock replacement, a virtually unlimited library of digital inserts can be printed inline rather than using pre-printed offset inserts, so long as the media is acceptable. This overcomes limitations at the inserter where you're restricted to how many bins are available. Moving to Inkjet typically introduces color capability to the output as well. This helps to improve the appearance of the application and helps make the introduction of dynamic messaging and promotional information more impactful and relevant. So the old way of storing an inventory of pre-printed shells, inserts, or the final output such as manuals can go away with the use of white paper inventory, and the printing of updated materials on demand where the overlays, variable data, and digital inserts are applied as jobs are printed. An important distinction to note with Solimar's workflow is that the data can be indexed all of the way down to the page and field level. This enables the underlays, messages, and inserts to be conditionally added to the output on a page-by-page basis. The underlays can be applied based on what tray selection the original stock was associated with, and it accounts for both the front side and back side forms as compared to solutions that have no conditional logic and must apply the same overlay logic to every statement. In addition, as the output is modified with the inserted pages or sorted, the relevant content such as sequence numbers and barcodes will be updated to reflect the new values. Here's an example of a typical white paper factory application. The source data started as AFP, so is converted to PDF, and in support for Inkjet, enhanced color overlays to replicate pre-printed stock is added. That includes adding dynamic messaging, along with colorizing elements of the page, barcodes and sequence numbers are updated, address processing is applied, and dynamic digital inserts are added based on the conditional logic. Keeping inkjet printers running at rated speed is a key area that many companies have a focus on, and the chemistry platform assists with this in multiple ways. Some common requirements the solution helps with are optimizing print streams so they process more efficiently, supporting various vendor-specific formatting needs such as resource caching, specialty font calls like Miker, color specification, flushing the inkjet heads by inserting pages with colored bars, embedding fonts, and supporting direct mail, commercial, print-on-demand, and transactional applications with a single solution. Keeping track of inkjet status and activity is also important for many companies with support for bidirectional information such as the job status, media, and ink usage reporting. Oftentimes, optimizing the output can delay the expense of having to upgrade your existing controllers to support new work, or on the flip side, enables new controllers you want to place to support your applications in the first place. For cost savings with inkjets, there are methods we can help with related production expenses, paper, envelopes, and inventory. This also overlaps with supply chain issues that you may be facing for paper, envelopes, and offset inventory. For using less paper, we can move simplex applications to duplex or to an NUP format. For NUP, we can shrink the original content so that it can fit NUP on the output. For this, you might take 4 or 8 pages and format it for a single sheet. Using a digital proof and approval process can avoid printing samples to review hard copy output. Doing reprints on non-continuous feed printers can avoid the waste that may occur when running smaller jobs on the continuous feed printers. There's also often application-specific ways to reduce the amount of print, such as schools and universities only printing the needed chapters or lesson plans required instead of the entire book. For envelope reduction, we support workflows to reduce the number of custom envelopes you may be using. Standardized address cover pages can be added, or the address content can be repositioned on the page if there's room, so it shows through a standardized windowed envelope. Householding the output and removing undeliverable addresses not only saves postage, but reduces the amount of envelopes needed for the mailings. Householding would combine multiple documents intended for the same recipient and do a single consolidated mailing for one envelope versus multiple mailings going out. And finally, using a white paper workflow allows for dynamic digital inserts and pre-printed shell replacement versus procuring them as offset jobs and having to store them. Formatting the output so it can be processed properly is the next area we'll explore. Output formatting often goes beyond just getting the printers running at rated speed, but supporting related aspects of the workflow such as finishing requirements. Some inkjets are continuous feed devices and commonly run the output 2-up as compared to cutsheet devices. Our workflow supports taking 1-up cutsheet applications and formatting them for continuous feed printing in 2-up or other n-up requirements. This process can format the layout of the output in multiple ways, such as imposition for books or book block formats. As documents are moved to new layouts and run on standard stocks, barcodes, inline perforation controls, trim marks, and quality controls can also be added to the output. We can also reverse this and deimpose files that are currently n-up to be 1-up or another layout for cutsheet printing or e-delivery. The page content can be shifted and scaled to make room for control marks if the original output does not have the necessary space on the pages as well. A couple of other value-add features Rubica supports are to help keep the quality up by adding color boxes to current or inserted pages to flush the inkjet heads. This keeps them from clogging when certain colors are not used for long runs of output. The second is to introduce quality control pages to the output. Rubica can duplicate records in the output and modify the address and barcode so they are not actually mailed, but can be kept for proof of quality. The barcode is set to the duplicated records are diverted at the inserter, and the address can be set to your company's address in case it actually goes through to mailing. These quality control records are useful to keep as a record of how the job was produced to validate internally or to show clients that there were not any quality issues within the print run. A case study related to the benefits of modifying the page layout is with IWCO. They installed new inkjet web presses, and the margins needed for the barcodes and other marks for the press were half an inch different from what the existing equipment used. This chip-out area is printed but then removed with the inline cutters. To accommodate this half-inch difference, they would have to upgrade many of the cutters that relied on fixed blades to use variable blades at a cost of over $110,000. They have thousands of composition templates for their client base, so modifying them was not very practical. Using Rubica's post-composition solution enabled them to quickly make the adjustments for the different chip-out areas needed for various application types. The IWCO case study video is available on our website with additional details. Reordering the job's print order at the entire file level or per record level digitally prior to the print is typically less expensive and faster than using mechanical rewinders. Going digital also can save you the floor space and maintenance costs of the rewinders. Inkjets also provide several workflow efficiency possibilities to print processes. Companies can standardize on fewer envelope types by adjusting the output address position or adding a cover page for flats and envelopes. The output can be segmented so jobs that use the same inserter setup or envelope type can be run together. This avoids having to adjust press and inserter configurations as much for various job setup requirements. Inserter control files can be generated to integrate with the inserter for job and item level tracking, integrity controls, and both closed-loop or open-loop automated reprint processes. And the barcodes can be adjusted for just-in-time inserter control so jobs can be printed to match the equipment that is available even across multiple sites. Job batching workflows are an important part of getting the most from the value inkjets can bring. This includes various concepts for combining files such as concatenation, assembly, householding, and commingling. The first level of batching files is concatenation. The concatenation process reads files in from a folder and combines them into a single optimized output file. This is commonly used for producing larger files from many small PDF files to improve printing efficiency and collating PDF files containing information common to a particular set of criteria. The process optimizes files by consolidating resources to make for more efficient output files. The next level of combining files is the assembly process, which is similar to concatenation, but reads in an input file that specifies what files to combine. An example workflow is to assemble chapters of a manual or the components of a mailing that should go into the same envelope. There's not a limit to the library of files that can be assembled since the process gathers the content based on what is in the input file list. This can be used to automate manual collation tasks to reduce costs and human errors with faster turnaround times. The assembly process also applies the same optimization of the PDF resources that the concatenation process does. The third level of combining files is job batching. This enables a processing flow that combines jobs with similar characteristics into a large batch jobs, sorts the mail pieces, and optimizes them for greater operational efficiency and cost savings. Jobs with matching attributes such as paper stock and finishing can be manually batched or scheduled for release automatically based on several scheduling options to help with meeting service level agreements. The batching process provides significant workflow improvement potential for anyone with lots of small or medium jobs that could be combined for mailing or production processes. Job batching is also useful to combine small jobs into larger print runs based on their due dates. Jobs can be held and gathered until they meet scheduling requirements before they are submitted to print, and the jobs can be gathered until a defined sheet count is reached in order to fill a production roll of paper or other production purposes. And when ready, the job batches can be manually or automatically processed. Another important part of job batching or combining files is that it enables increased postal savings for small and large jobs with digital commingling. By combining jobs into consolidated print runs and then processing them as a single job for postal processing, you get greater zip code saturation for increased postal savings. In addition to digital commingling, there's householding, which is the concept of merging multiple records for a recipient into a single envelope from across files versus sending them multiple mailings. For example, combining checking, savings, and money market statements info into one mailing instead of 3. Merging like information together in the process output is a good way to reduce mailing-related costs. It works by using common fields across the output files, such as an account number, to merge the records together in the final output. This means less mailings to save postage and less envelopes with the added convenience for consumers, and it helps support any green initiatives that your company may have. Additional green concepts include electronic delivery as an alternative to print, which also relates to reducing print-related costs from consumables. The archive system can also serve as part of a reprint solution where damaged pieces are commonly printed on cut sheet devices versus going back to the inkjet. Having electronic output available ad hoc is a value add beyond the printing of hard copy and expected by most industries these days. The final component is our SolaTrack dashboard, which is important for inkjet environments as it enables many of the inkjet-related concepts such as job batching, scheduling, job and tracking, down all the way to the piece level, proofs and approvals, distribution for the production process, and letting you know when things are going well or when there's an issue by providing alert notifications along with reporting. Overall, you have the print file optimization, maximizing print efficiency by creating larger print runs and batching like work together with digital commingling, with each step in the workflow being monitored down to the piece level tracking with SolaTrack. Keep in mind that our Solimar University online platform provides you with an online training resource with videos on various topics related to the solutions in our chemistry platform, such as installation, best practices, and configuration topics. Thank you for your time. We hope that you found the session helpful, and feel free to reach out to us with any questions.